Hi everyone, my name is Sophie Sparks and I'm here with my colleague Ben Moss, a consultant at the Information Lab. Ben Moss is Alteryx Ace and one of the best solvers I know. Ben's going to be taking us through this Alteryx Weekly Challenge number 200 and he'll be talking you through his solving process. Ben, I believe you haven't even looked at this Alteryx challenge yet, is that right?
I know what the topic is roughly, but I've heard it's a Sudoku challenge, but I haven't downloaded it or anything. I didn't want to cheat. But I may have set myself up to fail by doing that, but we'll see.
Very, very brave, Ben. So everyone who's joining, I will, if you have any questions, I'm going to be monitoring the YouTube, the live chat. So if you have any questions, drop them in there and I can reply to them, or I will ask them for, ask Ben you for them. And we'll see how long it takes Ben to go through this challenge. This, of course, has been recorded and it will be up on YouTube later on this evening as well. Right, Ben, take us away.
Thank you, Sophie. So I'm just going to start with a brief introduction about what the weekly challenges are. So Ultrix is a data preparation data science platform, and there are, as there are with most things in life, two ways to almost learn things. One of them is through taught teaching, and then one of them is by or through self-guided learning. Now, I am personally much better at the latter, and the weekly challenges fit in nicely if you are this kind of person who likes to challenge yourself rather than, you know, be taught in a more formal setting. So the way to access the Alteryx weekly challenges is via the Alteryx community. And then on the left side, there is a section called the Academy. Now, the Academy has a whole host of Alteryx learning resources. So there's some learning paths, some interactive lessons where you can go through and drag and drop tools. And there's also some videos on the different areas and tools that exist in the platform. And then finally, apart from the weekly challenges, we have the certification. So all of the Ultrix certification is free up to a certain level. So the first two exams are, and then the final one, which is the expert exam, which is quite difficult, is paid. I'm going to take you through this weekly challenge idea. Now, I am by no means one of the best or biggest advocates for weekly challenges. There are people much higher on the leaderboard than I am, but I do often say, like, these are one of the best learning resources out there. So from this page, where you want to go to next is this weekly challenge index. And upon that, they have a leaderboard of the top challenges. And what you'll see is that I'm nowhere near the top 10. A lot of people have got 200, and there are 200 weekly challenges. So it's been going for roughly 4 years now. And then beneath that, someone's even completed 148 in the last month. That's madness. And then beneath that, there is a list of all of the challenges from week 1 to week 200. Now, with each of these challenges, there is a web link to the communities page, which is specific to that challenge. There's an indicator of the level of difficulty and the kind of topic. So if you're a brand new user, the best way to start, we find, is to copy this table into somewhere like Excel, filter the table for beginners, and then go through all the beginner challenges before moving on to the intermediate and advanced. And as you can see on the right side, because it gives you the kind of subject that it's about, that's quite useful for trying to dedicate learning upon a specific topic. I'm going to scroll down to weekly challenge number 200, which is this week. And as I sort of mentioned briefly, it turns out that it seems to be some sort of Sudoku solve.
Ben, Sophie here. Your audio has just dropped out and we can't hear you anymore.
Which is excellent.
It's back again.
Back again. Sorry, Sophie. It says my internet connection is unstable. Let's see how we go. So for each weekly challenge, there is a blurb about what the idea of each of this challenge is. And then beneath that, there is a start file, which is an Alteryx workflow. So I'm just going to hit download. And once you've completed your Alteryx Weekly Challenge, the idea is that you post it so they can keep track, and that's how they build their leaderboard. You can also attach your solution, so that can help other users understand how you've gone through the process. And people also like to put an image, which just makes it a bit easier to see what other people have done. So if I were to click this spoiler, I might get some little tips on how to approach the challenge, but try to avoid that if possible, because that's some of the more competitive of us would say that's cheating. So the workflow is now downloaded. So I'm just going to open the workflow. I've got a versioning error, but hopefully everything should open just okay. And it seems to have. Okay. So the way the weekly challenges work is they have a input file, or in this case, a series of, so an input file. And then they also have the solutions written into the data. And there's also seems to be some sort of web link in this one. At the top, they all have that same blurb that was given at the top of the community page. So I'm just going to give this a quick read so I can sort of understand what the problem is. What I will also always do is just hit run. So all of those browse tools load with the relevant data for the challenge. Okay. So let me just read through it and then I'll come back to you. So I'm going to start with the beginner problem. So it says, using the beginner intermediate start file, parse the puzzle by separating rows 9 characters at a time. So obviously, every cell in the grid is given a value between 1 and 9. So they're always single digits. So that's obviously something that we can use to almost create a parsing technique. And then if I just look at so this is our start file, which you'll see is a really long string. I think I may have froze again. Good. Yeah, we're good. Okay. So I'm going to start by looking at the beginner solution. And you'll see that this is a 9 by 9 grid. And what it says is the columns and boxes then line up accordingly, where 0 represents an empty cell. So you see these zeros, they're the ones that we almost want to fill in with this challenge. So the whole top left corner in this Sudoku puzzle is taken out. So they're going to be the ones that we need to solve, I'm guessing, in the intermediate problem. So how do we parse data in Alteryx? Well, luckily for us, there's a few ways, and traditionally the methods revolve around these green tools that you see. So the text to columns tool in this case is one of my favorites, and it's almost everyone's favorite because it's an easy way of splitting data. If you go to the Parse toolkit itself, or tool palette at the top, there's a suite of tools dedicated to parsing data in Alteryx. One of the more advanced tools in this palette is something known as Regex, or regular expressions. And that's a tool that allows you to deal with parsing data through specifying, through string data, but you don't necessarily know what is contained in that string. You just know there's a consistent structure, if you like. So I know in this case, we've always got an 81 character string, and that every 9 digits we want to split our data. So that's there's a consistent way to parsing this information. So I'm going to grab a Regex tool and bring it onto the canvas and connect it to my beginner and intermediate starting file. Okay. The way the Regex tool works is you have the ability to select the column which contains the text data that you want to parse. In this case, we only have one column, so we don't have to really deal with that. We then have a few output methods, so we can replace values based on a Regex statement. We can tokenize data, which means splitting it to either rows or columns. We can parse data, which means essentially ripping data out and putting them in very specific columns, and then match, which will give us a Boolean result. In this case, we want to split our data into different rows or columns. So we could use tokenize or parse. Tokenize is a bit better for this because you can almost specify an unlimited amount of value. So I'm going to go tokenize. It then asks me whether I want to split to columns or split to rows. So I'm going to do split to columns, and I'm going to split to 9 columns. And then it's sort of in a bit of a weird order. You select your column, then decide a method you want to use, and then the actual regular expression that you use is in this middle box. If you hit the plus arrow, you can see like the array of different regex statements that you can use, or apply. In this case, we want to split our data every 9 digits. So there's this digit function, so I'm going to use /digit. Now I could do that 9 times, or there's a little cheat way. I don't know if it's given in here. It should be, might not be. Does appear to be. Where you can specify the specific number of characters. So use the little mustachio. You then specify the number of characters you want. So we want 9. And then we are closing the mustachio. Now, hopefully, if I run this workflow, I will get 9 columns, and you'll see that we do. So we now have 10 fields, it says there, but we keep our original data, but then we have the first row, the second row, the third row, 4th row, 5th row, 6th row, 7th row, 8th row. So in fact, it's probably better in this case to actually split to rows. So I'm just going to do that instead, split to rows, because there are rows of data. Okay. Now it's a case of bringing out the columns in our data. So 0 here is cell 1, 1. This is cell, if you think about it, row to column, 1, 2, 1, 3, 1, 4, 1, 5, etc. So we're going to repeat that exact process, but we're going to do the split to columns in this case. So I'm going to go to copy, paste, and then I can keep all of my statements. The only thing I'm going to change this time is I'm going to use split to columns, and I'm going to do 9. And it hasn't worked. Why hasn't it worked? Because this time we don't want to split every 9 digits, because there's 9 digits in each cell now instead of 81. We want to split every single digit. So I'm just going to remove that. If you just do /d without the mustachios, it just means a single one. Some other regex methods that you might use is a plus, which means 1 or more, or star, which means 0 or more. But in this case, we have a very specific amount of digits we want to pass. So I'm going to use that. And then you'll see we now have all of our columns with our single cell values in. And if I just compare against our solution, the only thing that looks a bit different to me is that Alteryx have gotten rid of that first column, which contained the original data. So to remove fields in Ultrix, there's a simple tool to do this process, which is via a select tool. So I'm going to bring on the select tool and just remove our quizzes column. And I'm also going to uncheck the unknown column, because I know there's only ever going to be 9 columns or 9 columns in our data, because it's a Sudoku puzzle. And then just visually eyeing up the 2 files, you'll see that everything seems to line up looking at the results window. Now, one thing you can do if you really want to be sure that your solution is correct is you can bring a join tool onto the canvas and join on each of the individual fields. Now, in this case, this is a bit painful, but I will do it just to show you what the result would look like. I'm going to run this. And it's telling me string fields can only be joined to string fields. So it appears, if I just look at the metadata, that these are all bytes, or they're like that's like a numeric data type, whereas in our case, these are all strings. So I'm just going to quickly change these. You can do that by doing shift, change field type of selected, and I'm going to change those to bytes as well. Now, when I run this, all of my records should join. I should have no records in either the right or left side. That tells me that my output is perfectly correct. So we've done the beginner part of the challenge. The next one is to actually solve the puzzle. Now, this is obviously where it gets a bit more complex. Okay. So in this, fortunately, I am sort of aware of how Sudokus work, but I'm not particularly great at them. So I'm going to see how far I can get before I drive myself insane and give up. But hopefully it's simple enough and solvable. So the way a Sudoku works, just for those that might not be aware, for every row, there must only be a single instance of each value from 1 to 9. The same rule applies for every single column, and also every single 3 by 3 grid that exists in our data. Now, in this case, all of our empty values, which are represented by zeros, as stated in the challenge, are our empty values. So I'm just going to think about this very quickly about how I might approach this challenge. So I guess there's a few starting points that I'd like to get to, or a starting point which I'd like to go to. So I want to move my data into what we refer to as a long and thin format. So I want a 81 row table with 1 value per line. And alongside that information, I want to have a column which indicates the row it belongs to, a column which indicates the column that the data belongs to, and then a field which says which box or sub 3 by 3 grid each of these things belongs to. So to do that, we've already got some useful starters because these are already listed 1 to 9. I'm also going to add the values 1 to 9 to our rows. So to do that, I'm just going to use a record ID tool. Again, just for the sake of consistency, I thought I could change this to byte. I don't appear to be able to. So I'm just going to call this row. And then I'm going to pivot my data. Now, to pivot our data into this long, thin format, we can use the tool called the Transpose Tool. So I'm going to pivot all of my columns around each of the rows in my already existing data set. And you'll see we move from this wide format to this long, thin format with 81 records. Now, the name field here is an indicator of the column with which the data comes from. So I'm going to use the select tool to just rename that column to column. Okay, and now I want to start looking at how I can create the grid value. So what grid or subgrid to what subgrid does our value belong to? Now, let me just think about that briefly. There's a long-winded way, which would be a nice if statement. I'm going to start by doing that just so I can move forward with it. But there's probably, or definitely, is a more efficient way of doing it. Now, the formula tool way would just be to create a column called, I'm just going to call it subgrid. I'm going to do it as a byte again. Yes. And what I'm going to do is say if row less than 3 and column 3, then 1 else-if, and then I'm just going to copy this a bunch of times. Now this seems really inefficient to me. 2. I'm just going to increment the columns first. I imagine there's a few people watching at the moment thinking, what the hell am I doing? So bear with me. And now I need to copy all of that. So and then let's just do this last one. Just do an else 9, because there shouldn't be any other permutations, and then close my if statement and if. And something's just got to arrive that I think I know what it is. So this should be 9. Okay. So it's saying there's an invalid type operator. So what that means is that either my row column or my column is of the wrong data type, because it's saying that I can't do a less than or equal to on it, which means it must be a string. So on my already existing select tool, you'll see that my column data type appears to be a string. So I'm going to convert that very quickly to a byte, and I'm also going to convert my row to a byte. As I said, I'm a bit of an OCD, or have a bit of an OCD, so that should solve that problem. Right. So what we see now is that we have our row column. So this, let me just go back here. So my value in column 1, row 1, belongs to subgrid 1, and the value is 0, 1, 2, and then if I just actually filter, which you can now do here, which is quite good, to 1, all of these should be my 0 values, because they're all in that top left subgrid. So every one of these values here out of these 9 need to be given a different value between 0 and 9. So there's a few ways we could go about solving this problem. And the first one I'm always going to think of is trying to do it via a brute force method, which probably isn't the best way. But what I know is that each of these values must be from 1 to 9. So what I could do is create a what's it called? Create a list of the different 9 values that they can be and append it to each one of these. So then I get the 9 different permutations for each row of data I may have. So let's do that. So I'm going to go. And there's a few ways we can create data in Ultrix. One is via the text input, and I could just create a list. I prefer a bit more of a dynamic way, just because it looks a bit cooler, to be honest, because in this case, it wouldn't really make a difference because the amount's fixed. So this is my value. And the value can be between 1 and 9. And the way this tool works is it's going to generate me a row until this condition is met. So it's going to start with 1. It's then going to do 1 plus 1, which is 2. and check if that's less than or equal to 9, which it is. And it's then going to do my loop expression again. So 2 plus 1 is 3, check, 3 plus 1 is 4, etc. until we get a meet our current condition. I should probably get rid of that pop-up while I'm at it, shouldn't I? So you'll see that we now have 9 records. And I'm going to put those against each of my rows that are of cells which are empty. So I'm just going to use a filter tool. Filter to where the value equals 0. Now, hopefully, this will help me solve the advanced one, but you know, who knows if that's actually going to be the case. I might get lucky here. And I'm then going to use the append tool, which is like a give me all combinations of 2 data streams. So yeah, it's going to give me, it's going to give me all combinations of them. And I'm just going to remove this source value column because that's always 0. And we're just going to keep our new value field. So let's run this workflow. I will add here that not all of the challenges are always this complex or mathematically challenging. So you'll see now for each of the different cells, so this is cell 1, we can have the value 9. Let me just filter this. Filter equals 1. Oh, not 11. Column equals 1. So you see that for column 1, we can almost have 9 different permutations. It can be either 1 to 9. Okay. So just thinking about where to go next. So these are the values that can change, and these are the values in our data that are fixed. Now, how can I do this? Just think. Give me a second. So they're all the values that each cell can be. So I guess in a brute force method, what I need to do now is almost create all of the unique scenarios that can exist. So for example, the first scenario would be 1, 2, 3, 4, 5, etc. And then the next one would be 1, 3, 4, 5, 6, 7, 8, 9, 2, or something like that. So we need to create all possible combinations now. The one way to do this would be to completely brute force it and append every single record against every single record. Now let me see if that will work. I don't think it will, but I'm just going to give it a try. You never know. This data source is now going to balloon massively, so it's going to give me 81 times 81 records. What's 9 to the 9? What's it called? Factorial. It equals 6,561. That number of combinations there could be. One thing that I do know is possible for sure is that we can't have I think I'd have to do this like 9 times maybe, but that doesn't seem like very efficient at all. I could probably do that with batch macro. It doesn't seem like the best way to go. If anyone has any advice, then let Sophie know and she can let me know. At this point, I'm struggling a bit. It's not cheating to look at the solution. It's just, it might give me some guidance on the best way to approach it. So that must be the first column. That's the first one. 6 3.
Hi, Ben. Sophie here. Would you be able to talk us through exactly what you're getting stuck on?
So what I want to get to a point of is for that little 3x3 grid that we're trying to create, what are all of the different combinations of numbers that I can put into that grid? So I'm essentially trying to create a string of 9 values, all ordered, a string of 9 values, which would be n number of rows long, because I don't know how many permutations there are, but it would be 9 factorial, I believe. That might be wrong. And then once I know all of the combinations, I can then join them with the other data, or the numbers that already exist in our table, to identify which one of those permutations is actually valid. So that's where I'm stuck at the moment, is how do I create that 9-character string, which says, okay, this is one possible option, this is a second possible option, this is a third possible option, etc.
Thanks, Ben. So it sounds like you need to break down your 81-character line, like string, into 9-character chunks.
At this point, no. So we're now working with the 9x9. So we're working with this top left only. So each of these values can be from 1 to 9. This could be 1 to 9. This could be 1 to 9. This could be 1 to 9, etc. And then, yes. So in theory, this would be. I then want to say, okay, for option 1, it could be 1, 2, 3, 4, 5, 6, 7, 8, 9. For option 2, it could be 2, 3, 4, 5, 6, 7, 8, 9, 1. Option 3 would be 3, 4, 5, 6, 7, 8, 9. So it's like how do I do or create all possible combinations of 9-digit string with each value between 1 and 9. Removing any duplication, of course, because that would break the 3x3 grid limit that exists.
I see, that makes sense. Thank you for explaining that to us, Ben. I have jumped onto the Ultrix Challenge number 200 website, since you asked that people might have some tips. I just wanted to see if any tips had been posted. People, in the first few pages anyway, seems like your initial idea of using a macro, quite a few people have gone that way.
Interesting.
And Terry, who's watching has suggested perhaps you could use the information from the false side of your filter to eliminate possibilities that are already taken in the respective rows and columns.
Okay, that makes sense. So that makes complete sense. So what Terry, I'm guessing is saying is that we have the value 1 in cell 1-1, but is that actually possible based on because at the moment I'm just looking at the rules within the subgrid, whereas I also need to look at the rows for the column and the row itself, which would help eliminate and reduce the number of possible permutations. So that's a good idea. Okay, so I'm going to move forward with that. So I guess to do that, what I need to do is, excuse me, I've just had a sip of juice. I'm going to delete this second one because that's just making my brain melt. So for each of my row and for each cell almost, I need to join it on the row and the value, which would remove values that can't exist. I can then join it on the column and value to remove further rows. So let's try doing that. So value to value, row to row. Let's just look at the result of this. So any joined records here are values in our data that are not possible. Does that make sense? So it seems to be eliminating quite a lot. Maybe that is right. So the value 1 cannot exist in row 1 because it already exists in column 8, cell row 1. Sorry, it already exists in row 1 in column 8, so that becomes something that's impossible. Value 1, row 1, column 2, yeah. So you'll see that actually the value 1 already exists on row 1, so it literally can't be part of the solution. So thank you very much for your guidance, the mysterious Terry. I'm now going to, so let me just delete that. Sorry, that's connected to the wrong answer. So the left side now is the possible permutations that still exist for the different values. So we seem to have been limited these quite significantly. Interesting. I'm now going to join this to my left side and I'm going to join to my left side, so they're the permutations that are still possible, and join that against my false. But this time I'm going to join on the value and the column. So we're now removing the options where the column, the value already exists in that column. And then on the left side, we now have 9 records. Now, is that the solution? Have I somehow got there thanks to the mysterious Terry? Because there's only 9 records here. I guess the only way is to test. So I need to bring it into this format of a long string. So what I'm going to do is take this left input, left anchor. I'm going to join that against our false anchor. So these are the essentially the values that seem to be correct. Join them to our false anchor. So we're now at our full complement of 81 possible numbers. And now I need to bring them into the back into our string format. So remembering the format, so there's 9 records, and that's a row, then there's 9 records, and that's another row. So what I'm going to do is summarize by my row number first. So group by row. And then I want to concatenate the values. Now, this isn't going to let me do that because the byte isn't a string data type. So I just need to change the data type of this field first. string. So group by my row and concatenate the value. I'm going to remove the separator. So this now should give me 9 records for each row. And then I can now concatenate that into the full string. So I don't have to group by anything now, I can just concatenate. Now that doesn't look right. Oh, if I 2, 3, 8, 6, 4, 7, 5, 1, 9. So it's not right. That's mildly annoying. So I got cited for no reason. So what am I doing wrong here? So this is all possible combinations of the different numbers that exist in our data. So let me just sort this. So row 1, column 1 can be 1, 2, 3, 4, 5. And here I say, okay, it can't be, it can only be one of the values. Filter. So what I like to do when I'm testing things is filter to specific scenarios. So I'm focusing on this top cell, if you like, which I'm saying can be the value 4, 6, or 7, whereas in the solution, the value is 6. Okay, so that's good, because obviously that's one of the values. So I'm just going to isolate the data every time I run it, so I'm not having to use the filter in the browser every time. So I'm going to filter to column 1 or row 1. Row equals 1. 1 and column equals 1. Now I'm always working with just those small subsets of data. The tool's not been configured. I configured it. So equals 1. Okay, so then it can be only 1 or 4, 6 or 7, and this one it says it's 6, which is what the solution says. So what am I doing wrong? Oh, is it because of the order? Oh, the sort order's not right. If this is what I've done wrong, I sincerely apologise. Row, column. No. Oh, so 6, the top cell now seems to be correct. So it's 6. Oh, maybe I'm still doing it. 6. So the second column should be, second value should be 4. I'll bring my data together in the wrong order. So that one's right. So let's try and do this again. So this time we'll do the second value, which if I'm interpreting it right, should be column 2, row 1. That's right. Column 2, row 1. Yes. So, column. So again, it's saying it can be 4, 6, or 7, and we're getting the value 4. Okay. So it seems like I'm always getting the right number, but I'm getting it wrong when I'm bringing all the data back together. So sounds or looks like I'm doing something silly. So column equals 2, just seeing if it shouldn't be any issue here. I'm just checking this is giving me the same value. So it's saying it's 4. Let's try column 3, row 1. This is 7. 6, 4, 7. So my sort, why have I not got enough records? Did I leave my thing out? That'd be silly. Oh. So, okay, so that is the solution. So thank you, Terry, and I apologise for leaving the filter tool in, which is why it wasn't giving me the correct string. Was anyone shouting at that, Sophie?
Not yet, but that last little bit, if you could just re-explain to us what the problem was, and also sort of that step-by-step process you went through to identify where the issue was.
Okay, so whenever I'm working on a large problem and I sort of know what the data should look like, which we do here, what I will tend to do is try and, let me just delete this for the moment. What I will try and do is isolate the information which should give me the value that is supposed to go there. So in this case, I know that cell that should be 6 is representative of the value that should be in row 1, column 1. And then this one is the value that should be in column 2, row 1, column 3, row 1. So I'm using this to kind of test how my workflow is performing. Now, what I know at this point is that this is where all of my original permutations are. So I could add a filter tool in at this point to just isolate and reduce the noise that exists in my data, because I'm just trying to focus on getting one of the pieces right at the moment before then trying to blanket understand if the whole solution is working. So I'm sort of minimizing the noise that surrounds understanding that. And I do this a lot whenever I'm on a call with my colleagues and trying to support them, is I'll say, let's just reduce the volume of data that is flowing through the pipeline so we can understand the potential issue a bit better and understand truly how the logic is performing. So by adding the filter step in here and isolating it to row 1 and column 1, I can then see just that smaller subset of data. So now I've got 9 records to focus on, rather than, or 9 records, but one specific answer of what I'm looking for. So I've narrowed down the pool of results we're looking for by almost 90% or so. So I can then follow this through the process. So after the first join, which is where I'm trying to remove any values that already exist on that row, I get 4, 6, and 7. So according to this result, I can only have the values 4, 6, and 7 for cell 1, row 1. Now, if I look at the table that we originally created, which is, where is it? Here. So row 1, so I've already got 2, so it can't be 2. I've already got 3, it can't be 3. I've already got 8, 5, I've already got 1, I've already got 9. So 4, 6, and 7 are still valid options. Is it 4? Is it 4, 6, and 7? It's probably not 4, 6, and 7. Yes, because we're focusing on just the row at the moment. What we can then do is reduce the noise by focusing on the column, which is where we then get to the value 6. So if I just go back here, it can't be, so we've now reduced it to either 4, 6, or 7. It can't be 7 because it already exists in that column. It can't be 4. So therefore, this cell value must be 6. And then I just walk through just another smaller subset just to check it's not just working by fluke on one of the permutations. So I'm then just walking through another one just to check it's working on that. And then just, after going through 2 or 3 scenarios and being sure that it's working for each of those unique scenarios, I would then just open it up and check the full solution is, what we're looking for. So if I were to delete and connect around, so to bring all my data through again, I just join this with the solution file. You'll see that I get 1 record through, so that tells me that my solution that I've generated with this, logic is sound. Now, I'm not going to go through the third problem on this call because we could be here for another hour, and I don't think many of us want that. I would like my dinner before 9 o'clock. But I believe this challenge, there is a actual Sudoku. So in our case, we had a scenario whereby just reducing the column and row permutations and looking at the object, then we can reduce it to a subset of values that it can be. And in this case, because we were just looking at I believe in the scenario, because the grid is so complete, i.e. we're only missing 9 values, there's only ever going to be one possible solution with this methodology that we're applying. Whereas in the case of this Wikipedia challenge, there is many more cells than just 9 missing. So I believe the method that we would have to go through is building probably a batch macro to beef out all of the different permutations. So I would, I've accidentally closed the solution for that. To beef out, sorry, let me go, great, let me get this straight, sorry. I would use this logic to restrict the number of possible values. So at this point, we're not going to end up with 9 records. I imagine we would end up with a lot more, but at least we've reduced the possible combinations. And we would also need a third join, because in this case, our whole grid was empty. But in this case, we do have some values in the grid, so we can reduce, the number of values further. But I'm still imagining the values or the number is going to be way more than 1 record per cell, which is ideally where we'd get to. But it might we might be able to reduce it to 1 or 2 or 3 different values. And then at that point, we're probably at a scenario where we're not going to build a massively computationally heavy process by building out all of those different permutations, which is traditionally possible by either a batch or an iterative macro, which allows you to layer data on top of the previous run and the previous run. So maybe it's thinking about that, maybe it's an iterative macro. But I also know that my former colleague and the Grand Prix winner, Philip Mannering, has some genius solutions for permutation building. So I'd probably also go and speak to him if I'm totally honest, because he is very good and has helped me with a client-facing problem, which is relatively similar-ish to this. So I guess I'm gonna leave now unless anyone has any questions, or Sophie wants me to keep going till 9 p.m.
Hi, Ben. No, I'm also keen to get dinner sometime tonight. So for everyone who's dialing in, I'm based in London and Ben is, where are you at the moment, Ben?
Leicester.
You're up in Leicester. Okay, so we both have I'm looking at a good hour and a bit commute to get myself home. So thank you so much for going through that. Anybody who has any other questions, please drop them into the chat and I'll ask them for Ben. This, as I did put in the chat, this is being recorded and will be up on the Information Labs YouTube channel later on tonight, UK time, I guess later on tonight if you're dialing in from the US as well. So thank you everybody for joining. Ben, are you going to post this solution onto the Alteryx Weekly Challenge 200 forum?
Yes, so I have a gap in my plan tomorrow where I'm going to. I'm too competitive not to finish this off now, so I'm going to try and get it done before I then post it up. Yeah. But I could post an early version just so we can attach it as a comment to our YouTube post. Maybe that makes sense.
That would be brilliant, Ben. Yeah, if you could do that, and then when you complete the advanced one, if you post that up on the same URL, that would be perfect.
Cool. Thanks very much, everyone.
Yeah, thank you so much for joining us, and Ben, thank you so much for doing this live.
Sure. Thank you for hosting, Sophie.
Great. Hope everyone has a lovely evening. Thank you. Bye.
Yes, bye.